Vur, fogo, fuer, flamar, fuego, tuli, palo, vatra, eldur, fuoco, bran, posar. A flame by any other name burns just as bright, and it's always combustion.
Since before recorded history, fire has played a key role in man's minds and lives. According to mythology, when the Greek titan Prometheus created man, his greatest gift to them was the gift of fire. Since receiving this gift, we really ran with it. Without fire, daily life would be unbearable, but how many know how and why fire works? Well, after this video, you can count yourself among the lucky few. Fire is one of the possible outcomes of a type of chemical reaction, known as combustion. All combustion reactions result in the release of heat. This makes them exothermic. Many, but not all, combustion reactions also result in light. This combination of heat and light often takes the form of flames, but can also manifest as glowing.
Chemically, a combustion reaction consists of a fuel reacting with an oxidant and yielding other chemical species. Technically, a fuel is any material that can store energy. However, in most cases, it is a hydrocarbon, which is any compound consisting entirely of hydrogen and carbon. The oxidant, or oxidizing agent, is any chemical that will remove electrons from another reactant in a reaction where atoms change their oxidation number. That's called a redox, or reduction-oxidation reaction, by the way. The major example of an oxidation agent is oxygen, but ozone, O3, fluorine, F2, chlorine, Cl2, and others are also oxidants. Thus, the typical reactants for combustion are CnHn plus O2, where N is any subscript. We'll leave the edge cases for AP.
Now for the products. Basically, when you have a hydrocarbon and oxygen as reactants, the products will be carbon dioxide and water, CO2 and H2O. In some other cases, other products are possible. In the case of single elements undergoing combustion, the product is usually their most common oxide. For example, nitrogen yields nitrogen dioxide. Though there are many other possible scenarios, this video focuses on the standard combustion form. Hydrocarbon plus oxygen reacts to make carbon dioxide and water.
How does it apply to real life? Well, one example is a typical fire. We have an example of this right here, the whoosh jug experiment. The jug is covered with alcohol, a fuel, and a hydrocarbon. The fumes build up in the jug. Then we light a match, another example of combustion, and bring it to the lip of the jug. The fuel, along with the oxygen in the jug, catches on fire. As you can see, combustion isn't just among the most widely used of reactions. It is also probably the coolest looking. Once our reaction finishes, we're left with the product. The CO2 is a gas, so we can't see it. The water, however, is right here. Remember how we poured out all the excess alcohol? Well, this liquid must be water then.
Nice shades. With that much swag, we might turn into single replacement. Don't worry, I have my own. Anyway, at this point, you might be wondering about other real-life examples of combustion, such as, what happens in your car engine. They have a hydrocarbon fuel too, so why don't they produce just H2O and CO2? This is due to a phenomenon called incomplete combustion. Incomplete combustion is far more common in the real world than complete combustion. In fact, complete combustion is extremely rare, and you can almost never actually find it. Incomplete combustion occurs when there is not enough oxygen for the fuel to completely react and produce pure CO2 and water. It results in various other substances as products, such as carbon monoxide or pure carbon, which is soot. Even the jug experiment is not truly complete combustion, since it uses air as the oxygen source, and air is mainly nitrogen. So nitrogen oxides were actually likely in the products, but we couldn't see them, of course. Incomplete combustion often results in chemicals that are toxic or harmful. Combustion's efficiency can be improved to make it less incomplete, and that's actually mandated by law in many cases, such as in our cars.
Now you know the basics of this key element of daily life. How about some combustion facts? Flames are teardrop-shaped because of convection currents in the air and buoyancy from gravity. If there was no gravity, flames would all be spherical. For combustion to occur, the fuel must be heated to the ignition temperature, activation energy. Fire moves upward because the combustion produces gases that are heated, and the heated gases rise over the cooler surrounding gases. The fire moves up with them. Spontaneous combustion is when heat is spontaneously produced until the ignition temperature is reached. The heat is from exothermic internal reactions. It can occur, among other things, in coal and pyrite.
You know what else combusts spontaneously? Pistachios and manure. Next time you're at a pistachio farm, be careful and be aware of combustion that's happening around you.
We won't make any assumption about its form or function, but this took some construction and much info reduction, so we hope you enjoyed our combustion production.